Hello there and welcome to the session on AWS S3 with Terraform, and this is going to be a little longer session because we are going to cover 8 different topics into this particular session. And in this session we are just going to deep dive using the S3 creation with our Terraform. So let's see what we are going to cover today. So first we are going to start with how to create your S3 bucket using your Terraform configuration. Second, we are going to take a look after creation of our S3 bucket that how we can upload multiple objects to that S3 bucket. After that, we are going to set up some security and we are just going to set up some KMS key so that we can enable the encryption for our S3 bucket for the objects which we have uploaded. Fourth, we are going to set up some custom IAM policy on our S3 bucket. Fifth, we are going to set up the versioning on S3 bucket so that whenever we upload certain objects, then we create a multiple versions of those objects. Sixth, we are going to take a look onto the lifecycle rules on S3 bucket and how we can impose those lifecycle rules on S3 objects. Seventh, we are going to take a look how we can create a bucket for logging. So we will create a one parent bucket where we will upload the object, but then we are going to create a one more bucket which is going to be a logging bucket which will store the log of our parent bucket. And at last, we are going to take a look onto how to perform the object locking onto the S3 bucket, and everything we are going to cover with the help of Terraform. Few more practicalities. So here you can find this is my GitHub repo where I have already uploaded the Terraform code for this S3 session. So all of the code you can find it over here, and I'll post the link of this particular GitHub repo into the description section, so feel free to clone it. And apart from that, I have also posted the timestamp of each topic. So if you are already familiar with some of the topic, then you can just skip those topics based on the timestamp description. So take a pause over here, take a look onto the topics and see which one is suitable for you. If in case you are new, then you can just start from the topic 1, like how to create our S3 bucket. Alright, so let's start with our topic 1, which is like create our S3 bucket with Terraform. But before that, I would like to give you a little brief about this particular project. So when you clone this particular GitHub repository, then you will find a S3 folder, and inside that folder, you will find a main.tf file. And this file contains all the different tasks which we are going to accomplish today. So there are total 8 topics which we are going to cover today. So all of those are over here. So whenever you begin with this particular GitHub repo, then there are few variables which I have created. So here you can see this is the Terraform variable, and these variables will be used to create or assign the bucket name to our bucket which we will be creating using Terraform. Secondly, there is a remote backend which is needed for Terraform to store our Terraform state file. Refer to the Terraform course in case if you don't know anything about Terraform. I have already uploaded a course on Terraform, so just go and refer to the whole Terraform. But if you are familiar with the Terraform, then we need to create a remote state bucket. So this is the bucket which I have already created on AWS. So if you take a look over here, then onto my AWS console, go to S3, and here you can see I have already created this bucket manually using this GUI button for create S3 bucket. So this is the prerequisite for running this project. So you can create your own S3 bucket with your own custom name, and then you can assign into this particular Terraform code bucket over here. Rest like EC2 setup, and this is the key which I have created because I have been using the same folder. If you go inside that one, here you can see this is EC2 setup, but I'm just using the same folder to store the state file of all of my projects. So that's why the name is there. But in case you can even change the key name also, that should be okay. And apart from that, the region, so since I'm working into the Europe region, so that's why I have specified EU Central 1, but in your case, you can specify whatever the nearest region which is for you in AWS. All right, apart from that, also there is a few things. I'll clear the screen onto terminal. So you need to also install the AWS CLI. So here you can see after installing the AWS CLI onto your system, you just need to run the command AWS configure. And once you enter this command, then it will ask you to supply the access key and secret access key. So you need to enter those AWS access key and secret key, which you can find here. You can see it is asking for AWS access key, and once I enter the access key, then it is going to ask for AWS secret access key. So that you can find from here. Go to your account, go to the security credential, and here you can generate the access key and secret key from here, so that you can just work with the Terraform code, which can authenticate using the access key and secret key, and then you will be able to create your S3 bucket or any other resources in AWS. All right, so let's get back to the main.tf file. I'll close everything over here, and we are just gonna focus on the step number 1 to create our S3 bucket. And for the simplicity, I'm just gonna comment out whole other code so that it is not gonna create some confusion, and we are gonna enable this code section one by one once we start achieving our task. So if you take a look onto the task list, so this is the first task list where we are gonna create our first S3 bucket using Terraform. So here you can see, first of all, this is the resource block which is really needed to create a S3 bucket. So the resource block is AWS S3 bucket. This is the name of that particular resource, but don't get confused. This is not the actual bucket name. It is the name of this particular resource block. That's it. Apart from that, here we are going to specify the name of the bucket. So if you'll see over here, I'm passing the bucket name variable, and that variable has been passed from here. Here you can see this is the variable, and the default value is my demo test bucket, and the type is string. So the value has been passed from there. But if you have noticed over here, then here I'm passing the random hex. Why it is needed? So whenever you create your S3 bucket, then S3 bucket names are global and unique. So if someone have already taken that particular bucket name, then it will not allow you to create that particular bucket. So for that reason, what I have done, I have just created a resource which is a random ID resource, and that generate a hex of byte length 8. So this is a random hex which is generated always for me. So whenever I create a bucket, then it is going to assign some random hex at the end of that bucket name, so that it is always unique, and I don't need to worry about searching for the unique name of my bucket. But the initial part of the bucket name is always fixed, so I don't need to worry about the initial part, and I can easily identify this bucket belongs to which region, what is the name of it. So that's some of the practices we use whenever we are working with the S3 bucket creation in our actual day job. All right, so now you're familiar with this one, and you have already seen our S3. I can show you again. So here you can see there are only 2 buckets, and now we are going to create our own bucket using Terraform. So let's get back to terminal, and I'm just going to open the terminal. Let me open into the windowed mode. Here you can see I'm just going to cancel this one. I don't need it. Let me expand the size of this particular terminal. I'll just clear the screen, and I'll just shorten the path so that it is visible to you also. And here I'm just gonna use the sign, not this one, maybe this one. Yeah, clear it. And the first command which I'm just gonna run is Terraform init command. Sorry, I'm not into the directory. So here you can see I'm into the AWS codes repo directory. So I need to switch to S3 directory, clear the screen, and then run the command Terraform init. Alright, so now my Terraform init has been successfully initialized. The next command after clearing the terminal I'm just going to run is Terraform plan, and it is going to tell me that how many resources it is going to create. So here we are going to create our S3 bucket. Here you can see it is planning to add 2 resources. So 2 resources are, one is S3 bucket and one is the random hex ID. Alright, so go back to your terminal once again, open the terminal over here, clear the screen, and then run the command Terraform apply, type yes to execute it. And here you can see our resources has been created. All right, so let's get back to the terminal, and not terminal, but the AWS GUI, refresh it. And here you can see our bucket has been created. So if I click over here onto the bucket, then here you can see this is the hex which I have added at the back of my S3 bucket. All right, and this is this random ID is not a resource on AWS. It is just a local random hex which is generated by Terraform for you. All right, so this is our first task, and which you can see that we are able to create our S3 bucket using Terraform. Let's move to the second task, and in the second task, after creating a bucket, I need to upload few objects to S3 bucket, and those objects can be a single object or more than one object as well. But to explain to you, I'm just gonna upload more than one object so that you feel comfortable that you are able to upload single as well as multiple object to S3 bucket. So here onto my terminal, I can show you here is the folder which I have created images, and here I have pasted some of few PNG images, and also there is a one index.html file which I have put it over here. So I want to upload all of the 4 files, 3 images and 1 HTML file to my S3 bucket. And these files are called objects because everything we work in the S3 is known as object. There is no concept of a file in S3 bucket. Okay, so now I'm just going to enable the second block, which is this one. Here you can see here I'm just going to upload. Just wait a minute and I'm just going to explain the whole code to you. I'm just going to comment the remaining block, which we are going to see soon. So here, this is the resource block which is responsible for uploading the object. So the name of the resource block is AWS S3 object, and this is the name of that particular resource block. Here I'm using the for each loop because in the image folder there are more than one file. So here I'm specifying the path of my images folder, and here I'm telling that upload all the objects or files present into that particular folder. Apart from that, this is the name of this is the bucket ID which you need to specify, and that we are passing it from here. So here you can see AWS S3, the name of the bucket resource, and then the ID, because here we have created the bucket, but for uploading the bucket we need to pass the bucket ID so that it can identify which bucket ID the resource needs to be uploaded. All right, the key here, key is the name of the object, whatever name we are keeping over here. So these are the name of the object, and these are coming from each. This is the for each loop, and this will bring in the key of that particular object. So it will iterate one by one object, and the key will be the name of that particular object. Then we need to specify the source from where we are going to upload it. So the resource is the path, which is this one, which is images. So here I'm specifying the path. Also, I'm just going to enable the MD5 checksum on those particular files. So this is the value for enabling the MD5 checksum. So this is also a good practice whenever you're working in a DevOps job, cloud job, then enable the MD5 for your S3 bucket. Secondly, also I have enabled the server-side encryption for my S3 bucket. And apart from that, I have just assigned few tags, custom tag to my S3 bucket. All right, so let's give it a go and try to run the Terraform plan and apply. So I'll clear the screen, and the command which I'm just going to run is Terraform plan. And here you can see it is planning to add 4 resources, which 4 resources are our 4 files. I'm just going to clear it, and here I'm just going to run Terraform apply. And since I know this code, I have been working, I have done few iterations, so I can just do the auto apply. But in case if you are working in production environment, then don't use the auto apply. Since I know this code, I have worked multiple times, so that's why I'm using the auto apply flag. But in your case, just don't use the auto apply, just simply use the Terraform apply and then manually pass the command S so that you know that what you are going to execute it. Then hit enter. I think I just made a mistake over here. I'll just clear the screen and then run the command Terraform apply. Type yes. I think I made some typo in the command, but anyway, I have just run them manually. And here you can see the 4 objects has been uploaded. So let's get back to our S3 bucket, and here you can see the bucket was completely empty. Now I'm just going to refresh it, and here you can see all the 4 objects has been uploaded to my S3 bucket. All right, so now we have completed our second task. The next task is we need to enable the server-side encryption using the KMS key onto our S3 bucket. Although we have some default encryption, but to get it more secured, I would like to use the KMS key encryption onto my S3 bucket, which is more like industry practices which you need to follow to keep your content secure, which you have uploaded onto your S3 bucket. And there are a couple of steps which we need to do. So first of all, we need to create a KMS keys, which is gonna be used for encryption. And then we are gonna assign the bucket ID, which we want to encrypt. All right. So for that, let's get back to our IntelliJ, and here I'm just gonna enable the resource block. So here enable first this one for enable the KMS key, and I'm just gonna disable the code from here from the task 4, which we are gonna take a look later. Okay. So here, first thing, we are going to create a KMS key, because for creating the encryption, we need a KMS key. So here, this is the resource for creating the KMS key, the name of the resource, description, why we are going to use the KMS key, the deletion window, because KMS key cannot be deleted. There has to be a certain deletion window for KMS key, and the default is 7 and maximum is 30, I guess, if I remember it correctly. But I need to check the documentation, but you need to enter the deletion window for your KMS key. All right. So this will create a KMS key for us, and then we need to create an alias for our KMS key. I'm just going to show to you how it looks when we create our KMS key. So this is the name of my alias for my KMS key, so that I can use that particular KMS key using the aliases. All right. And here I'm just passing the key ID, which has been created from here. All right. So once we create a KMS key, which is our part 1, then we need to enable the server-side encryption. I'm just gonna hide this one. So here we need to use the resource AWS S3 bucket server-side encryption configuration. This is the name of the resource, and here we need to pass the bucket ID, which we have created in our step number 1, which is this one. All right. And here, so here we have already passed the bucket ID, and then we need to write a rule, and in that rule we need to assign apply server-side encryption, and here we need to pass the KMS key which we have just created, which is this one. Here you can see AWS KMS key, S3 bucket KMS key, and this is the ARN which I'm passing, and the algorithm I'm keeping it AWS KMS because I am creating my own KMS key. All right, so let's go to the terminal once again and clear the screen and then run the command Terraform. I have already run this code, so I'm just going to directly run Terraform apply. Type yes over here. And it is going to first create a KMS key, which you can see over here. And once it is creating the KMS key, then it is going to assign it to our server-side encryption for our S3 bucket. Okay, so here let's get back to our terminal, and first of all, let's try to search the KMS. Click on KMS key over here. And here you can see our KMS key has been created. So this is the S3 bucket KMS key alias, which I have already told you. So it has been created. And yeah, so this is the basic description or the properties of our KMS key, which is already present into our AWS account. All right, so now again go to S3 bucket, go to S3. And also we have applied this configuration on our S3 bucket. So click on this bucket over here, and after that go to properties, and if you scroll it down, then here you can see the default encryption, and now we have set the KMS key for that encryption, and here you can see the ARN. If you click on this particular KMS key, then it is again going to take you to the same KMS key which you have created. So now your AWS bucket is encrypted using the KMS key. If you are liking this kind of a content, so before proceeding, I would like to show you one thing. There is also a membership program which I run onto my YouTube channel. So here you can see there are more in-depth session on how to use the cloud and DevOps, where I have shown like more in-depth session on and industry practices. So if you are interested in those kind of a session, then please join the membership. So here you will find an option onto my channel to join it. So If you are interested, then just try to join the membership program of my channel as well. So of course you will get some kind of a special benefit apart from the free content which is available onto my channel. Let's get back to the topic again. Alright, so now we have seen the KMS key and encryption. The next thing which we are going to take a look is the bucket IAM policy. So whenever you go on to your S3 bucket, in our case, this is our S3 bucket. And if you go to the permissions, then here you can see the bucket policy section, which is this one. And this bucket policy section is completely empty as of now. So we have not defined any custom policy, IAM policy onto our AWS S3 bucket. So in this chapter, we are just going to create our custom policy and we are going to put some restriction on our S3 bucket. And those restrictions are, if I can show you our Terraform code, let me first enable this code from here. And I'm just going to disable the task 5 as of now. So here, these are the custom policy. First, take a look onto the policy, and then I'm just going to explain to you the whole Terraform code. So this is the policy block, and here you can see we are just allowing the get object, which means you can only view the object. You cannot update the object, you cannot modify, you cannot delete it. So this is a custom policy which I'm just going to impose onto my S3 bucket, which we have just created. So here I'm passing the bucket ID, which you can see, and here also I'm passing the policy along with my S3 bucket. Okay, but apart from that, I also, to apply this policy, I need to make my S3 bucket public. So if you take a look over here, then here the public access, block all public access is on, which means this S3 bucket is completely private. But here in this block, I'm just gonna set that bucket to public. And I'm just going to define a dependency also over here, so that first, before executing or applying this policy, it is going to enable or make it public. That's why I'm using the depends on block, and once it is enabled to public, then it is going to apply the policy to that S3 bucket. Alright, so let's get back to terminal over here, clear the screen. The command which I'm just going to run is Terraform apply. Type yes over here, and it is going to take a few minutes to enable that particular to force and make it public our S3 bucket, and then apply the policy. So I'll be back once this is done. All right, so my policy has been created. So if I go to my AWS S3 console, then I'm just going to refresh it, and here you will see this is on and it will become off now. So here you can see now we are allowing the public access, and also you can see we have updated the policy. And what this policy tells you that we are just allowing the get object or the read object permission. You are not allowed to modify, you are not allowed to delete, or you're not allowed to perform any other operation apart from just get the object, which we can test also. So go to the same bucket and just go to that index.html. Copy this URL, go to the new tab and try to hit it, and it will allow you to download that particular object. So here I'm hitting enter, and here you can see it has downloaded that particular object with that policy. So this is how you can customize the policy on your S3 bucket, and you can make it more restrictive onto your S3 bucket. If you are liking this kind of in-depth content onto this particular channel, then please consider subscribing to this channel. That means quite a lot for me, so that I can feel motivated and I can produce these kind of content for you guys. Alright, so now we have seen how to apply your custom IAM policy on our S3 bucket. The next thing which we are going to take a look, like how to enable the versioning on the objects, so which we have uploaded already. So which means, like if I go to IntelliJ and if I show you the objects, so here you can see there are 4 objects, one is HTML and 3 images. So I can enable the versioning on those objects as well. So if today I have uploaded an index.html and tomorrow I'm just going to modify that index.html, then it is going to create a version including the previous as well as the latest changed version. Okay, so let me show you how to do that. So for that, let's get back to the section 5 and enable this section specifically, and then I'm just going to put a comment on to this particular 6th step. So enabling the versioning is pretty simple. We need to pass the bucket ID, we need to use the versioning resource, and then we need to set versioning configuration enabled, and that's done. So what I'll do, first of all, let me show you the S3 bucket also. So here, this is my S3 bucket. Here is my index.html. So let's check the version. So here you will find the version tab. Click on it, and here you can see the version doesn't have a versioning enable onto this particular bucket. Okay, so now we are just going to execute our Terraform code to enable the versioning. Go to terminal, clear the screen, run the Terraform apply over here, type yes, and here you can see we have enabled the versioning. Let's get back to our S3 bucket, and here just refresh this page and this warning message should go away. So here you can see the warning message has gone away and it has created the first version. So whenever you work with S3, then the first version is like a null version ID. So now you can see our bucket has created a version for our object. So let me show you one more thing. So what I can do, I'll just update the index.html page, and here I will type update. So I have updated my index.html page, and now I want to upload that index.html page once again. So what I need to do, I just need to apply that, simply need to run the Terraform apply. It will automatically upload. So run the Terraform apply over here, and it should show the change of that particular file. And here you can see one to change. It is not going to create, it is just going to modify that file. Type yes over here. And here you can see it has uploaded and modified that index.html, which you can see. All right, so let's get back over here and then just try to refresh this one. And here you can see the version ID. This is the second version, and this is our first null version. So it has created a multiple version of the same file because the one is the older one and one is the new one, which I have recently updated. So this is how you can enable the versioning on your S3 bucket. Now, after learning the versioning, the next thing which we are going to take a look onto the lifecycle rules. So we can set some lifecycle rule onto our S3 bucket. And what are those? So let's take a look onto our IntelliJ. Let's get back to the code. Open the main.tf, and here I'm just going to enable the task 6, which is this one, lifecycle rules, and I'm just going to disable the task number 7. All right, so here few of the rule, and here I have written the short description. So let me do the wrap of this one. So here you can see. So we can set a custom lifecycle rule onto the S3 object. So here the rules, what it says, after 30 days becoming a non-concurrent. So if our object becomes 30 days old, then object version are transitioned into the standard IA for a cheaper storage. So which means like our S3 standard is a very costly resource when we use our S3 bucket as a standard S3. So after a certain period of a time, if object has not been used and it is on staying on the same version, then we can transfer that object to some cheaper option of our S3, which is our standard IA, which is cheaper. So here I am setting a 30 days rule onto it, and after 30 days it is going to move to standard IA. Then after 60 days it is going to move to the Glacier for long-term storage, and after 90 days it is going to be stored into some deep archive of our S3 bucket, which is more cheaper to do that. So here again, so this is the lifecycle rule resource. Here I'm just assigning the bucket ID, and here we are just gonna define the rule, and here I'm just putting the ID as a config. Prefix I have assigned as a config. It is custom, you can choose whatever you want. And here I have assigned the non-concurrent version expiration, so 90, 30 and 60. So here you can see Glacier, standard IA. So this is how I'm just going to define the custom rules, and finally we need to set the status to enable it. Otherwise you will not be able to see those lifecycle rules. So let's get back to our S3 bucket and see if there are any rules which I have applied. So go to, I think, management, and here you can see the lifecycle rule is completely empty over here for my S3 bucket. So get back to our terminal on here, clear the screen, run the command terraform apply, And here you can see our lifecycle rule has been created. So if I go over here and refresh this particular lifecycle tab over here, then here you can see the config rule. Click on this config rule and here you can again verify the same detail. So objects become non-concurrent 30 days, then 60 days, and then 90 days. Okay, so after that it is going to be permanently deleted. So this is how the lifecycle rule will work into your S3 bucket. So customize these rules and policies and then set the lifecycle rule for your own S3 bucket. All right, so now we have seen the object lifecycle rule. The next thing which we are going to take a look onto the logs. So if you create a one bucket, which we have already created, and if you want to monitor the logs, whatever operations which are happening onto this bucket, the one which we have created, I'm talking about this particular bucket. So if any operations are happening onto this bucket, then where I can store the logs of these S3 bucket. So for that, we are just gonna use the logging bucket to store those logs. So let's take a look onto the code first of all. So I'll just go back to task number 7. I'm just going to enable the task over here and just disable from task 7. So for that, what we are going to do, we are just going to create a one more S3 bucket to store the logs. So this bucket, this bucket we have already created, and here you can see there is only 3 buckets. So now we are going to create a one more bucket which is going to store the logs of this particular bucket. And how to do that? So here you can see this is the simple code to create a logging bucket with the name my demo test logging. And after that, we are just going to write a resource block, which is S3 bucket logging. And this logging resource will create a log inside this bucket, which we are just going to create right now. So all the operations which are happening on this bucket, which is our main bucket, all the logs will be stored into this newly created bucket with the name my demo test logging. Let's go to the terminal over here, clear the screen. So just give me a minute. Clear the screen, run the command Terraform, apply, type yes over here. And here you can see our log bucket has been created and the logging has been set to that particular bucket. So let's get back over here, go to the buckets over here and then refresh this page. And here you can see our logging bucket has been created and this is our main bucket from where it will store the log of this particular bucket. Also, you might be wondering like how should I find which log bucket it is created, because if someone else has created those log bucket, then how would I know? So what you need to do, just go to the bucket for which the log bucket has been created, which is this one. This is not a log bucket, but this is our main bucket. Go to the properties, and here in this properties, you will find an option for a server access logging. And here you will find that particular option. So click on this one. And now we are into the logging bucket where the logs will be stored. So this is how you can figure out like where the log bucket is and what is the name of that particular log bucket. Moving to the next topic after the bucket logging, the next one is the object locking. So once you have uploaded any object onto our S3 bucket, then you can do the object locking on that S3 bucket. So how to do that? So for that, let's go to our IntelliJ first of all, go to the eth task. I'm just going to enable this task. And here I'm just going to remove all the commented code. So this is the object locking. This is our AWS S3 bucket object lock configuration. Here I'm passing the bucket ID. And here I'm just setting the default retention rule for 1 day. So once it is uploaded, then you cannot delete those objects for at least 1 day. So that's the locking rule I'm trying to set onto my S3 bucket. So if I go to terminal over here, clear the screen and then just run the Terraform, apply, then it will create that particular locking rule. Type yes over here. And here you can see our locking has been created on my S3 bucket. Let's verify our object lock settings. So again, go to the bucket. This is our demo test bucket. Go to the properties. And here in the properties, if you go to further down, then you will find an object lock, and here you can see this is enabled, and the default retention is 1 day, and the retention mode is compliant. So this is how you can enable the locking onto your S3 bucket objects. So with that, we conclude our S3 session with Terraform. I hope you have enjoyed this session, and please put down any comment into the description section, and soon you will see another session on S3 bucket using the CloudFormation. So we are going to do the similar exercises using the CloudFormation template with our S3 bucket. And don't forget to check out the other session, DevOps project. There are quite a lot of things I have already uploaded onto my channel, so go and take a look onto those topics as well. See you in the next session. Till then, take care and bye bye.